Still video? Okay, yeah. So the activity is going to be very simple. You know what the density is, right? What the density? The mass or volume. So if I'm going to have this spot, it's made of aluminum, and the other one is made of the steel. The mass of the steel one is going to be heavier for the same volume. The steel is going to have more density. That's actually how the thing's working. And we talked about why the thing is happening. Changing the alloying of the material will change the density at the same time. Today this is going to be very simple. We have these cubes. Okay, it's made of different metals. We don't know what the dimensions are, but they should be all equal. Simply because of the machining and the cutting operations, maybe the difference in the dimension will be appears. Well, I can take one of these blocks, been taken by individual students. Get the vernier. You learn now, you know, by the way, how to use it by now. So you take the dimension of this cube. Take the three sides, and then you can calculate the volume of it. Right? Easy job. We have the scale here, and simply by turning it on, again, to have the problem is the resolution we have is just in grams. I don't know why it doesn't give us the fraction of the gram. So I put it on the scale. For example, this one is 19 gram. I know the volume, change that to kilogram, change the volume to cubic meter, calculate the density, take the name of the metal which is written here, and leave the work till here. Okay, now that's what you have to do in the lab. Each student again to take one of this cube, write down the weight, the mass, the volume, and the density. When you go home, make your own research online. What the density of this material? What the actual density of this material? And that's why I got, this is the real thing, why we have a difference. Just write the brief. There's not going to be anything to be submitted. You know the textbooks we're going to have, text box we're going to have, discussion boxes we have in every module. You are going to have one of them just to write down your opinion about why we had the differences between the densities during the measurement process and the actual one which is tabulated. You can have many reasons, like for example, the wrong measurement, sensitivity of the scale, right? Also, in the tables, maybe it's not going to be the pure metal, maybe it's going to be for the alloy. So all these discussion points, very simple thing, just put something like one paragraph in your discussion. I will allow the discussion between the people, so it's not only me going to see the discussion, your colleague will see that, and they're going to be able to like, reply, or dislike your analysis. But in all the cases, don't worry about that. It's something like it's your own experience. It's not about what actually something to be graded for. I can give you another example to know. For example, I don't know what this metal is. I know it's steel, but if I don't know what the grade of this is steel, what will be the best way to know that? Weigh it. You find the mass. Calculate the volume by what would be the easiest way to calculate the volume for such parts? Put in water, yeah? And you're going to have displaced water, and this will be the volume of the part. So you know the mass, you know the density, calculate the volume, and you're going to be able to know what actual material or what the grade of the steel that this shaft has been made of. Oh, by the way, when we're going to do some calculation for this one in the mini project, I'm going to show you how actually we can make a simpler way to find the wasted material of this part by the machine. We're going to talk about this one very soon. Okay, so I think that's it. That's what we're going to do. Have the vernier from the box, have one of the cubes, prepare your paper, or you can put that on your mobile phone, just write down for the activity of the 22nd of August. The cube I had was, take a photo of it, and the dimension where, and the mass was. Just write down all these things and you can finish the rest of the activity at home. So you can go around now. I need a volunteer to be the first student who's going to be recorded here, and you're going to be popular because everybody will see you on YouTube. I don't know, my channel is actually closed only for the students. So you can come here and you're going to be the first one. Go ahead. Yeah, go ahead, mate. Right there. Okay, now everything you're going to do, you have to tell your colleagues in the video what you've done.
Right.
Okay, so get the cube, get the vernier, and do the measurement. Now for the rest of the student, we have two skills here. We can work in parallel. Don't worry.
Anyone have any questions regarding that? Or
Wait,
what
so
we're
I
gonna
do
do?
it, tell the,
Yeah, just show them the steps.
um,
Show them what the metal you
it's
have.
the cube, it's tungsten,
What the metal, what's written on it.
tungsten.
Tungsten. Okay, just tell them that. Show close to the camera. Okay.
Tungsten.
Yeah, dimensions.
Um,
First check if this one going to go to 0 when you close it.
this?
Yeah, does?
Yep.
Okay, now do the measurement. Remember that not all the cubes had the same measurements. Are you recording that?
Oh yeah, I should be right.
No, you write down. Okay, you can mention that because you can check yourself later in the video.
True, yeah.
Yeah.
Okay. Is 10 by 10.
Is it 10 exactly?
It seems to be, yeah.
Wow.
I highly doubt it.
It's close.
I highly doubt it. Do you know how to read a vernier scale?
Hmm?
Do you know how to read a vernier scale?
This is the first time I've used
Okay,
it.
let me check that for you. Okay, so what we have here
9.6
is...
when I checked.
Now, okay, now the 0 is not on the 10. It's between the 9 and the 10.
Okay.
So we will go for the first line, which aligned in the mini scale.
Okay.
So we can see that actually the 8 is the best aligned line. At least that's what I can see for myself. Yeah, the 8. So this one is going to be 9.8 millimeter in
Okay.
this side. Let's check the other side. Okay, so I said 9.8. I'm talking to the camera now. So he will be able to check the dimension later. Now for this one is little bit less than the 9.8. I can see this one is 9.7. 7 is the best.
Yeah. Okay.
Okay, I'm not getting to the health. I can see the 7 is the best. Okay, now the last dimension is going to be this one. And it is, which one is the best one now? I think 9.7 again.
6, I'd say.
You can see the 6.
Yeah.
Okay, and that's, to be honest, it's 9.65.
5?
Yeah.
It's just between the 7 and the 6.
Okay.
So 9.65.
65.
Now, the mass, turn on the,
Oh.
and the mass we're going to have for this cube is 19 grams. Okay, now he can calculate the volume, have the mass, change all the kilograms, and you can find what the density is.
Awesome.
Now the others follow up. Thank you very much.
Are we doing all metals?
Well, it's going to be their selection.
Yeah, so selection of metals.
Yeah, okay, now come on guys, I'm going to stop the recording and